Hello all, we are learning a state flow. In a state flow, we have finished the flow graph and state chart and all these things. So in a state flow, we have started with this where we have learned the important thing is like Simulink and state flow are a powerful combination where the system needs a response both continuous and discrete changes. And the Simulink provides us a continuous changes and state flow provides us a response to the discrete changes. Okay, so that's why we require both to make some stable subsystem output, like stable output for customer requirement for that. So we require Simulink and state flow both, and Simulink or state flow are a powerful combination. In a flow graph, we are learn how we can draw the flow graph, if else condition, if else if condition, through the various condition we have run there, and again we have done with a coke dispenser machine in that way, coke juice dispenser in that way. Okay, next we have done with the states where we have learned how we can create a state, how we can control the state with on or switch entry during exit condition, state action like state label, state name. We have learned so many things regarding to the state. Okay, now we will learn the decomposition in a states. So we have just now done with the states. Now we have to learn the decomposition of a state. This is a very important thing where every MBD person must need to know. I will relate this thing with we have done that variance of system. Okay, there anyone can be work at a time that I can relate with a exclusive or. Okay, and if we have like normal non virtual subsystem, okay, means no, virtual subsystem means non-atomic subsystem, or it can be allowed to go with the flow in that way for the end. We can say in that way as well if you want, but mostly we will I'll tell you in a simple way also. The state first I'll define the what is a state decomposition, what we have to know about this. So state decomposition specifies the type of subsets and supersets can have. So there are two possible decompositions for a state. One is OR, that is exclusive decomposition also known as. So we can say exclusive OR decomposition or exclusive decomposition, or we can say OR decomposition. So we can say any one of them. And another one is AND parallel decomposition. We can say AND decomposition, or we can say parallel decomposition, or we can say AND parallel decomposition. Not both the things are same. So all the subsets must have the same type, identical to the superset. Decomposition within a superset, in the case of exclusive decomposition, only one state can be active. Whereas in the case of parallel decomposition, multiple states can be active simultaneously. State decomposition, where I want to know much more thing about the state decomposition and what is this state decomposition. So for that, what I told you that in the case of exclusive decomposition, only one state can be active. Okay, in exclusive decomposition. So in a case of parallel decomposition, multiple states shall be active simultaneously. So state decomposition can be set using like right click. We can do, I'll show you that right click exclusive or exclusive decomposition we can do from that. So here if I'll come inside the chart, the decomposition is there. From here I can select exclusive or parallel, what I have want. Okay. So now we will learn about what is exclusive OR and what is parallel. So exclusive OR decomposition is like OR decomposition, also known as exclusive decomposition, describes the system with mutually exclusive operating states. We can say that if a state has OR decomposition, then only one out of its multiple subsets will be active at a given time. So in OR decomposition, only one state can be active at a given time. Okay, and if we are the states decomposition of a newly created state is by default OR decomposition. So by default, these are OR decomposition. So it can be observed that subsets within a OR decomposition states are displayed with a solid outside board. So I have told you how it will be given. It will be having a solid outside border. You can say these are the my states. Okay. And by default, any one state can be active at a time. So I'll show you with a step forward operation. Now I have simulated a model with one step ahead. So you can see only one step is active. Now it is off is active because L output is 0. Then it will turn to the on. And next step, okay, and it's finished. That you can see now only one should be active at the time there when I will be running for the or decomposition or exclusive decomposition. So what happened in the parallel and decomposition? If I change that to the parallel and decomposition, so and decomposition, also known as a parallel decomposition, is used to describe the system with mutually exclusive operating states. For the states with a and decomposition, all of its subsets will be active simultaneously. The subsets as a part of an decomposition state have dashboard. So that multiple states should be active at the same time. It will run at the same time. So for that, I'll show you. I'll make this parallel and okay. And now you can see the states are become a parallel and if I will run this, so you can see it will run simultaneously all the states together. Previously, it was not running at a time. Only one was run, another was run, and third and fourth. In that way, it will be happening. Now all states are run together. You know, parallel and decomposition. But by default, Simulink gives us a exclusive or decomposition. First, I'll finish this. Then I'll change that. By default, it's exclusive or we have changed to add. So here you can see in this diagram state 1, state 2, there's state 1, 1 and state 1, 2 and state 2 is state 2. So this shall be discussed in various level, their decomposition. So number 1, what is a pairing chart or a decomposition? So state 1, state 2. These are to the state 1 and state 2 known as a pairing chart. Okay. Can be like means mutually exclusive states, solid borders. These two states are mutually state 1, this state 1 and this state 2, that outer side. Okay. And having a solid borders which indicates that at a time either like state 1 or state 2 can be active. Okay, for this. Another one is state 1, where state 1 inside it we have OR decomposition. So OR decomposition, what is by default, anyone can be work at a time. So here you can see state 1 dash 1 and state 1 dash 2 will be work both like one by one, but will not work at a time. Anyone can be work at a time. But inside it, we have state 1 dash 1 dash A and 1 dash 1 dash B. These are the and decomposition. And if that state 1 dash 1 is run, that means that both states should be run together. Okay. That means that both states should be run together. So in a state 2, this is a and decomposition. These two are the and decomposition. So both should be worked together. But here it is my R decomposition. So are mutually exclusive. Both the states have a solid borders. These states are having solid border and these states are having dotted border. So and states are having a dotted border and all states are having a solid border. Okay, that thing is known as very important thing. Like draw as a dash border, you can say, or dotted border, you can say what you want, you can say for that. So decomposition concept can be like much more good. We have to know about the decomposition. Most of the MBD interviews or like model-based development persons knows about the decomposition and how we can use, where we can use. We have various applications. So where we can use, suppose if we are implementing some water dispenser, we want hot, cold, or like normal water. So in that way, any one all state can be work at a time because the person is pressing both buttons together. So it will may impact. Only hot is placed, so hot is water coming. Cool is placed, only cool is coming. Normal is placed, no. So in that scenarios, we can use the exclusive and decomposition. Okay, or parallel decomposition. We can say that same thing. And that the one more thing is like in exclusive or decomposition, we have used the parallel and decomposition. And here you can see in the parallel and decomposition, inside it we have used the exclusive or decomposition. So these kind of transitions also possible. These kind of transitions are also work. So if that things is asked like where, how is it possible we can call the like parallel decomposition inside the or exclusive decomposition? Yeah, it's possible. Okay, so that's all about the decomposition. And decomposition is allows all to run together, and where all decomposition allows only one state to run at a point time. Okay, that's a simple summary. Thank you.